Region, the focus of this competition. Today, we're going to be hearing pitches from 12 student teams from the New York City metro area, and judges will select a regional winner who will go on to compete at the national competition to be held in April at the Energy Thought Summit in Austin, Texas. They may also be nominating several regional nominees for the Technology Bonus Prize categories. Before we begin, I just want to offer a few introductions. So I'm Tammy Rosanio, Associate Director for Partner Programs at Syracuse Center of Excellence, one of 14 NYSTAR supported Centers of Excellence in New York State. The mission of the New York State Centers of Excellence is to leverage university expertise and assets in specific areas of focus to support the growth of companies and economic development throughout New York. At Syracuse COE, our work focuses mainly on energy efficiency in buildings, as well as indoor air quality, renewable energy, and water resources. We work with the U.S. Department of Energy on several faculty-led projects, as well as with several of the national labs. Our partners in today's competition are from NYSERDA, New York State's Energy Research and Development Authority. A public benefit corporation, NYSERDA has been advancing energy solutions and working to protect the environment since 1975. We have a new video from NYSERDA that we'd like to share with you.
New York's path towards what is possible. The charge we
Can you hear it?
on climate change, fueled by new technologies and innovations, new strategies, and a relentless commitment. Together, all of us continue to pave the way for cleaner communities across New York, toward hope, toward opportunity, toward realizing a cleaner, more sustainable future, so that tomorrow and the next day and the day after that, New Yorkers will have smarter choices about how we use energy. Hopefully, the examples we set will help lead others, and our road less traveled will just become the way. The path to a clean energy future is a long one, but with the help of everyone here, our path is a path to possible.
Thanks, Carrie. We're also joined today by Hannah Pauling from the National Renewable Energy Lab, NREL, at the U.S. Department of Energy. Thanks for being with us, Hannah. Now it's my pleasure to introduce our judges for today's regional competition. First, we have Brad Benikowski, Entrepreneurship Navigator with NYSTAR. Brad has a long history with the Simon School Venture Capital Fund and is a startup consultant. In his current position at NYSTAR, he works with entrepreneurs to facilitate connections to resources in New York State, providing coaching and strategy advice targeting companies' growth. Thanks for being here, Brad. Michelle Knapp, founder of FundForm. Michelle has more than 20 years experience as a hands-on owner of a full-service property development, design, build, construction firm, as well as technology developer. Michelle's been involved with multiple technology development projects with the U.S. Department of Energy, including the Advanced Building Construction Program, the eRobot Prize, and the Building Envelope Innovation Challenge. Dr. Eric Schiff is a professor of physics at Syracuse University. Eric is the past executive director of Syracuse COE, and he has a long history of leading complex research projects targeting solutions to national energy challenges. He's been a principal investigator for research projects from the U.S. Department of Energy, National Science Foundation, and Empire State Development Corporation, and has served as a program director at ARPA-E, where he initiated the SHIELD research program, targeting inexpensive, high-efficiency retrofits for single-pane windows. Eric has supervised a portfolio of projects on solar energy conversion and other energy technologies. Casey Shuntrumpf, Program Manager, Climate Tech Programs at Second Muse. Second Muse is a partner in Venture for Climate Tech with NextCore. Cassie works on a variety of projects, carrying out program management and other responsibilities. Her work involves research and development, fundraising, and relationship building efforts for go-to-market strategies and market entry projects. Thank you so much to all of our judges for participating today. For the teams on the call, you'll see that our judges are identified in the names. If you hover over photos, you'll see that they've marked their names starting with judge. Now it's my pleasure to introduce you to our moderator for today's competition, Kai Volsi. Kai is a student at Syracuse University's College of Sport and Human Dynamics, where she's working to complete her degree in public health. Kai is from New Jersey, and in addition to her role as communications assistant here at Syracuse COE, she's also associate producer of Health Etc. Let's Talk Health radio programming. We're really thrilled that she's here joining us today to moderate the program. Kai, I'll let you take it from here.
All right. Thank you very much, Tammy. That was a lovely introduction. And welcome everyone to the competition today. I'm really excited to be moderating. Before we get the show on the road, we'll just review a few of the guidelines to keep things running smoothly. So for student teams will be limited to 7 minutes per pitch. There'll be a 1-minute warning given in the chat box. After that 7 minutes are up, the judges will be given 3 minutes for a Q&A session, followed by just a couple minutes, 1 or 2 minutes to record their impressions as the next team is preparing to pitch. So during that little transition period, we'll have the next team up, put their slides up, and not necessarily go right then, but when the judges are all wrapped up, we'll go ahead and start the pitches. So you can use the chat box at any time if you have any questions. And just a last reminder that this competition will be recorded and used by the U.S. Department of Energy. All right, good luck to everybody. And I think we'll begin by having Team 1, Trash to Power from New Jersey Institute of Technology, share their screen so that they may begin their pitch. If they are here. Again, that's Team 1, Trash to Power.
So I see Phil Silva was on the line. Oh, there he is.
All right. So they can go ahead and share their screens.
Hello, can you hear us?
Perfect, yes.
Okay, sorry about that.
Oh, you're totally fine, no worries.
All right, share screen. Sorry about that, we had to change some settings.
Sure.
And now my screen's frozen. Oh, there we go.
All right.
Ooh, there we go. All right, can you hear us clearly?
I can hear you. I don't see anything on your screen, however.
Uh-oh, what is it currently showing?
It just says that you've started screen sharing, but the screen is black for me. I don't know if that's everyone else's experience. Okay, I see it now. All right.
Right on. Okay, sorry. This took a second to load in. So, we are Trash to Power. My name is Philip Silva. This is Eric. This is Steven. We are electrical engineers at New Jersey Institute of Technology.
So Phil, can I interrupt you? I'm so sorry.
Yeah.
You have a message that's blocking your screen share. It says Zoom quit unexpectedly.
Yes.
Uh-oh.
Looks like it needs to be X'd out.
Oh, do we lose him? Technical difficulties. I mean, what would this be without him, right?
Oh, there we go. Can you see our screen now?
I can see you. I can't see
The screen sharing went off.
No
Sorry
worry.
about the problems.
Sure, it's fine.
Screen share, screen, specifically that one. All right, any problems?
Don't quite see the screen yet, but hopefully it'll pop up in a second.
I believe it says it's loading.
Perfect. All right.
There we go. All right, so starting from the top, we as a team are Trash the Power. My name's Philip. This is Eric. This is Stephen. We are 3 electrical engineering students at the New Jersey Institute of Technology. Uh-oh. Did it crash again? There we go.
So one of the foresights a problem. So we see landfills growing every year, and majority of these wastes are food. So these are biodegradable waste products. And another issue would be just seeing on the news the fact that China stopped taking our recyclable waste to the country. So that prospect means that these biomasses and these landfills are increasing year after year with that.
Oh, I think we might have lost you again, guys. I'm not seeing the screen share anymore here. Oh, are they still on the call?
Looks like they're having connectivity problems.
Yeah, I think.
Oh, okay.
Back.
It should be loading again.
Okay.
I don't know why this isn't working properly. The school's Wi-Fi is not working.
All right. I see that you are sharing screen, but it's just black again. So loading.
Yeah, it might be loading. Why is this happening? Are we back onto the first problem slide?
I don't see any slides at the moment. It's just a black screen. I don't know if that's everyone else's experience also, but
Yeah, it's loading.
all right. Happens to the best of us.
It's really unfortunate. This is the first presentation.
Perhaps we should try website.
It's got to be a Wi-Fi issue.
Yeah, I'm thinking so too. I'm not sure what the alternative is.
No, the video of them is frozen too.
Yeah, I'm seeing that.
Let's, they need to, let's go on to.
We might just go on to number 2 and let them fool with this.
Yeah, let's try and give them some time to work that out. And if we have team 2, the future of solar cell, also from New Jersey Institute of Technology. If you guys are on the call, we'll be happy to hear your pitch now while we let team 1 work out their technical difficulties here.
Hi everyone, this is Divya Tikani. I'm from team number 2. I hope you can hear me well. Okay, I'm gonna start my screen sharing.
All right, perfect.
Just confirm once when you can see the screen.
Yes, I can see your screen. Perfect.
Okay, so hi, good morning everyone. Our team is presenting the topic future of nano photovoltaics, or you can say nanostructured solar cells. Our team consists of 4 members, Abhi Patel, Neil Patel, Aiden Orto, and myself, Divya Tikani. We were lucky enough to have 3 professors as our advisors for this particular project. And let me begin with it. So, introduction to solar energy. We have been hearing it since we were kids, like solar energy is this and that. So I'm just gonna give you a one-liner gist that sun is a huge power source because of all the nuclear fusion happening on its surface, and it continues to provide us energy every day, which is equivalent to 173,000 terawatts. This is a huge amount of energy, and more or less, we can use this particular energy that we receive on Earth by utilizing the photovoltaic effects. using photocells. And that way we can convert this into electricity. Now, the environmental factors that are considered for this particular project is the same, like I mentioned earlier, that sun being one of the largest power source here, it provides almost, just a second. I'm so sorry. Okay. So sorry, I was trying to adjust the screen. I was not able to see the slides myself. So, considering the environmental aspects now, like I said, the amount of energy it provides is huge, and it's almost equivalent to 10,000 times of the energy that we need in the world, like the total world's usage. So even if we successfully convert 1% of it, we should be sustainable in the future, and we can eliminate our dependency on the fossil fuels, them being the renewable source, and they are decommissioning at a higher rate considering all the population, global warming and everything. So we're thinking about the sustainability and the long term. This is a project that we need to focus more on. And more or less, it provides carbon-free and green energy. That's a huge goal. So our business plan will more or less hover around the technology that we are going to use into this project, the market aspects and the economic feasibility and the potential impact it has on our society, business and customers, everyone. So just to touch base upon what exactly is the nanostructure for photovoltaic is, this particular structure is based upon nanostructured device, which is kind of an improvised version of dye sensitized solar cell. So this nanotechnology was introduced by microelectronic industry, but we are now exploring it to combine with the photovoltaic effects that we use to convert solar energy into electricity. And this particular technology is not different. As you can see in the initial screen, there's this aerogel level here, and then it is covered with the titanium dioxide. There are certain dyes and the electrolytes. The cell structure is similar to any other cell for this particular device as well. The only difference between the technology is the ALD technology that we are using. The lab that is working on this particular technology has atomic layer deposition technology, which is the reason that particular solar cell, like the photovoltaics of this particular technology, are way cheaper in cost. Now, coming to the customer analysis, for this particular project, we believe that every possible customer out there is our customer and can be our customer. So starting from residential areas to the commercial and industrial areas, as well as large and utility scale plants, solar plants, all of them can be our potential customers. The demand for this is gonna rise in future, because once it comes into the market, the price, it's comparatively cheaper than the typical crystalline silicon solar cells, while providing better efficiency and what you can say, the cost is low. So the returns are gonna be higher compared to the traditional solar cells that are now more in the market. This particular diagram, I'm using NREL sources here. These are the existing technologies that are there in the market. As you can see, silicon has been kind of like stable throughout the beginning of the time. From 1990s, you can see the stable efficiency of silicon cells here that are being used. But there are other technologies that are coming into market. You can see here some of the hybrid ones are there with more efficiency, but considering all the factors, their popularity is not the popularity is not much yet. And considering only silicon is stable throughout this duration, we have compared this particular, compiled this chart where we are projecting how cost of silicon panel solar cell will be different from a nano PV panel cost. And just like I mentioned earlier, the whole ALD procedure makes it way cheaper. So the photovoltaic cell are gonna be comparatively almost like 70% lesser in cost compared to the silicon cells over here. And as per the market analysis, there are multiple technologies in market. We are well aware about it, but there are too many benefits into the solar PVs. That's the reason we are trying to push this one into market now. So what makes it different? The major points, like I highlighted earlier, is the energy efficiency. It's gonna be more efficient than the silicon cells, and the cost that we are getting out of this is comparatively very low.
30
And more,
seconds left. Thank you.
okay. You're saying I do have 1 minute, or is it?
30 seconds left. Thank you.
Okay. So we do have, these were the two major issues that we were facing, the cost and energy. So we have a solution in this for that. And the marketing strategy is to target all the 4 Ps. We are going to focus on product, price, place, and the promotion of this. All the existing customers are going to be, our potential customers. They can switch from silicon cells to our nano cells. And we have to promote this using the expo centers, workshops, and everything. You can see this is the demography of all the existing customers here. These are the average prices of silicon solar panels throughout United States and different regions here. So whenever, if they decide to switch onto the solar PVs, it's gonna be cheaper than this. And the product strategy is primarily based on the 3 factors. Like if you provide good cost, efficiency, reliability to any customer, they'll choose your product. And the growth rate is exponential. So like in 10 years or so, you're like going up, straight up. So that's a very good industry to invest into. You have so many reasons to invest because of sustainability and booming industry. There are incentives, and like I said, the greenhouse emission and everything, all these factors we have to consider into the future. It's kind of like now more or less ethical reasons for us, as it says here, to invest into this particular technology. Thank you so much for your time.
All right. Thank you very much. That was lovely. We'll now give the judges about 3 minutes to ask any questions.
Sure.
I'll jump in. What's the comparative efficiency to this solution compared to typical silicon solution?
So efficiency is gonna be more, we know that for sure. I don't want to say it's gonna be exactly double because that particular data is not available yet, but it's gonna be definitely more.
And when you're saying you've got the end user of the solar panel, or are you going to be manufacturing solar panels, or will you be selling this technology into manufacturers of existing panels or existing manufacturers?
Either way, we are just looking for investment. We can put the manufacturing plant together for the solar PV, or we can sell the technology if we find a suitable buyer for it and get the price out of it, because it depends upon how you want to go with it. Either we can keep the partnership with them so that they can invest and hold some equity into the business.
Okay, so your end user or your customer is still looking for definition?
No, so end users will get solar cells as the product, right? So we are gonna be, so this particular business plan is to publicize the technology that's gonna be used in the business of manufacturing solar cell. So end users are the users of solar cell. I hope that suffices your doubt.
All
Are you-
right.
Are you a marketing company or a manufacturing company?
we are into technology as of now. We can go into manufacturing if we find a particular partner, because like I mentioned, as for our initial analysis, the investment is huge. And it almost takes like a decade to get back that kind of returns before that particular business is self-sustainable. So we definitely need sponsors, and they can be partners, they can hold equity, or they can just be silent investors, angel investors.
Thank you.
Okay, we'll now give the judges a couple of minutes to record their impressions and scores. And in the interim, we'll have team one get set up and we'll jump back over to them. They seem to be ready now. So just a couple of minutes. All right, judges, if you're ready, we'll have team one try again here. They seem to have it working now. So team one, if you're with us, you may begin.
Yeah. So we transferred laptops and it seems to be working now.
Great.
And everything is viewable, correct?
Yes, yes.
All right, then we are ready to start. Sorry about the inconveniences before.
Oh, you're fine. Go ahead.
So we as a group are Trash to Power. The main group is handled by me, Philip Silva.
My name is Eric.
And I'm Steve.
We're all electrical engineers at New Jersey Institute of Technology.
So one of the problems that we first noticed was the fact that landfills are constantly increasing over years, and what is in those landfills. About 25% of those are yard trimmings and foods, and those are biodegradable masses. As well as when I said the increase in landfills, a lot of landfills are close to just the general public, so it does cause health complications. As well as, I don't know if you've seen in the news within the past few years, the fact that China stopped taking our recyclable goods. So landfills are constantly increasing over years, and there's no prospect to decreasing these landfills. And these landfills cause multiple problems when I said about health related ones by living near them, as well as just the general methane gases that get emitted from them. So these methane gases can cause damage to the ozone layer, increasing global temperatures, as well as solid food waste and landfills do equate for about 17% of all of the methane emissions. So if we can ever decrease anything, I feel like this is completely plausible.
So we've been thinking about how we could really create a solution to these kinds of problems. And the main thing that we've kind of landed on is starting with the collection of these different kinds of plant material, either that be directly from the source of different individuals, such as people throwing out trash that might be able to be transformed into fuel, throwing out different scraps, landscaping, and general uses like that. From there, we then go on to the transformation of these kinds of goods, where we treat them and get ready for really turning them into some kind of fuel, such as ethanols, biodiesel, and things of the sort, and then getting ready for the distribution of those kinds of biofuels, where we could send them out to different companies to use as fuel in different endeavors.
All right, so diving into the collection aspect, our group plans to communicate with towns, cities, and restaurants to donate their waste plant mass to produce clean energy for the United States. Our plan is to propose that residents of towns and cities should leave out their waste plant matter for collection. For example, after your lawn gets mowed, the lawn shavings get left out and the city has to pick them up. our plan is to basically capitalize on that and pick those up ourselves and transform that into energy, of course, with the approval of those towns and cities. Europe is also big into recycling and already does initiatives such as this, and it shouldn't be too difficult to incorporate within the United States.
From that collection stage, we need to get ready to break down these mixed plant matters, turn them into a mash, and then treat them with things such as engineered enzymes. At Sandia National Laboratories, there's actually work and development on a type of extreme mephilic organism that is able to attach to these kinds of plant matters and make it a lot easier to break down the carbohydrates in them into actual usable material, which we could then turn into such fuels and biopolymers. From there, we would store those different fuels on site and get ready to refine and bottle them up to be sent out to different companies such as utilities or to consumer markets through different distributors.
And speaking of utility, I find it most fascinating the power generation abilities from these biomasses. Nowadays, the capabilities of them have been increasing year after year, and we're reaching about 10,000 megawatts capabilities from biomasses. And this should be sufficient for, let's say, New Jersey's power where we live in, because a lot of the power lines here are running about 230 kV. So it'll suffice, and as well as I think it's an investable business strategy for the state of New Jersey since they plan to be 100% clean energy by the year 2050.
So this is really the entirety of our main team again. I'm taking up the team captain for this. We have Stephen here leading on the collection, Eric here leading on the power generation distribution, and we also have our mentor, Professor Grebel, helping us out along the way to really help to develop this. All in all, trying to structure this entire project to push out really as solid of an idea of getting all these materials, transforming them, and sending them out, acting as one main line to really optimize the entire chain. Any questions?
All right, thank you for that, judges, as they've asked. Any questions?
I'll go first. Do you know of any other efforts to do this type of work, or have you seen any other pilots or companies working on this type of trash to renewable?
So there are multiple types of different endeavors. Unfortunately, I cannot name any specific company right now, although I do know of different examples, such as in Europe, where this kind of collection is very common and then turned into such biofuels. Even here in America, we already have the collection of some of these materials, such as grass. I'm sure you know, if you put it on the lawn, the city will come collect it. They then take those kinds of materials and then turn them into different things like mulch and compost. So we would really be stepping in and adding an extra part to really reduce that landfill potential and increase a more of power generation across the entire US.
And have you looked at, are these regional efforts, or when you say across the US, what's your pilot area would be New Jersey, as you're saying?
Yeah, so the pilot area would definitely be New Jersey, but this is something that is expandable to any town within the entire state.
Yeah, one of the pros of being in New Jersey is the fact that it's a very densely populated state. So there's a lot of food waste, kind of within a stricter parameter. And landfills it's more of an issue because growing up by me, we had a landfill in the same town, and everyone just said, oh, put it like far away. But at the same time, when you're densely populated, you need to figure out how to use these sort of garbage and waste things efficiently when you're in a tight knit area. So that's why I personally did believe New Jersey would be a good state to handle all this.
And have you done any initial takes on what the startup cost or manufacturing costs would be for the plant?
Unfortunately, at the moment, we don't have any exact numbers, although we are aware of some of the main things that would have to be that would have to go into something like this, such as finding proper land, as well as perhaps registering for different types of government subsidies, trying to figure out really the collection system. There is already some infrastructure in place of collection. We just need to find out how to tap into that with the cities to use it to its fullest potential.
Do you have any idea how much you might be able to sell the biomass or biofuels for?
As for cost, I believe the going rate for ethanol was right around $3 a gallon. Yes.
And how does this differentiate? I know the engineered enzymes is something specific you mentioned, but how does it differentiate from anaerobic digestion specifically?
I believe with that process, it's a lot more
Time-consuming.
it is a lot more time consuming due to the complex and the complex carbohydrates and materials within general plant matter. With these kinds of enzymes, it's able to more closely target those kinds of complex carbohydrates and break them up, so that things such as stalks and leaves would also be open to being used as biofuel instead of just the fruit, so to say, of any plant.
Mm-hmm. And do you know the scalability compared to anaerobic digestion? Like per pound of food waste, is it generating more or less biofuel than?
Unfortunately, I do not. Us as a group have reached out to Sandia National Laboratories to find out more details on the material, the actual enzyme itself, to get more details on it, but we have not yet been informed about such thing.
Oh, all right. Thank you very much, Team 1. We'll now give the judges a couple of minutes to record any impressions and scores while we allow Team 3, TransX Automated Transit System, to share their screen and prepare their slides. Thanks.
Thank you for your time.
Thank you.
Thank you. Again, that's Team 3, TransX Automated Transit System from Rutgers University. Feel free to share your slides while the judges are recording their impressions. All right, great.
Hi, can you hear us well?
Yes, just give us 1 second while the judges are wrapping up and we'll go ahead and get started with you guys.
So I think team 1 needs to stop sharing.
Yes. All right. Team 3, feel free to begin when you're ready.
All right, thank you. Hi, hello everyone. My name is Andrei Dimitriou. I'm joined today by my teammate Vladislav Stepanov. Today we'll be presenting TransX Automated Transit System, or otherwise known as TATSM. This will be a grid enhancing technology focusing on using heavy lift drones to assist in the installation of transmission towers and reduce the environmental costs for transmission owners.
Yeah, so about the technology, this is centered around the use of unmanned heavy lift drones, which work together to lift various heavy components of transmission towers, as well as heavy machinery used to actually build these towers. These drones will never leave federally owned land to reduce risk and to make the whole compliance side of things a bit easier. During takeoff and landing, human operators will be operating these drones and working with crews on the ground to coordinate the lifting operation. This means that the majority of the distance is actually requires no human intervention and is actually totally automated, thereby reducing the human labor costs and transport costs.
In addition, this idea of a technology is already brought about using sky cranes. Most oftentimes for independent system operators such as MISO or even PJM, oftentimes you have towers that need to be installed in remote locations, and helicopters are used as a means to assist the ground crew in erecting the towers on site. Now, for our project, what we're focusing on is the installation cost and reducing that value. As such, MISO in their transmission cost estimation guide for MTEP 22, they refer the installation cost to be the cost to haul, assemble, and install the structure, as well as assembly. We will be using the drones to assist in the assembly and installation of the structures, and as well as but being able to reduce the cost of what would be previously used by the sky cranes. So as we see in the table here, what we have several costs associated to each transmission tower rating. And the installation costs can range anywhere from $20,000 to $80,000 per tower. However, with the use of our heavy lift drones, we see that we can bring up savings up to roughly 20%. In addition, with the heavy lift drones, there will be a reduction in the need for forest clearing and as well as service roads to access the sites as well. And with that, we hope to see even additional savings to the project.
So we think this idea will basically benefit every single stakeholder in a power line transmission project. So the developers are able to take on renewable projects which were previously not viable thanks to the lower transmission build costs. The ISOs will have more money to spend on transmission upgrades. The consumers will see lower energy prices, and the environment will not be as impacted by transmission build projects.
With that being said, the project will assist with the clean energy transition by allowing for more renewable units to be developed and interconnected to the grid. With that being said, in addition, the project will allow for more transmission towers to be easily installed at a lower cost and will reduce the ongoing grid congestion and transmission troubles that we're currently seeing in both New Jersey, but also in North America itself. We also see that our project will reduce the amount of service roads will be needed, minimizing the transmission line project environmental impact. Furthermore, we can also see that with our project that there will be an increase or improved rate of project builds or rebuilds, which will further expedite America's clean energy transition. That'll be our presentation. Thank you very much for listening.
All right, thank you very much. We'll now invite the judges to ask any questions.
This is Eric. I'll ask a first question. You said a 20% reduction in installation costs. Where does that number come from?
So it's basically napkin math. There is a lot of information that we don't have that we would need to have, to create a more accurate estimate. This is largely based on our estimates of human labor costs and our estimate of how much human labor cost we could remove through the use of our technology. We're also cognizant of environmental credits, right? So, similar to carbon credits, environmental credits, you have to pay if you're damaging the environment during your build project. We know they're very expensive, and we know that if we can reduce the amount of them needed, we will reduce the total cost of the project.
Okay, thanks.
So how many heavy lift drones does it take to do the equivalent amount of work as a sky crane? And what's the difference in price?
So we say drones, we really mean a computer operated sky crane like units. So we would distribute the load across several heavy lift helicopters. So depending on how safe we want to be with this, it can be between 2 and 3 of these heavy lift units for every sky crane. We don't intend to lift anything super heavy, so we will limit ourselves to heavy machinery like diggers and stuff like that, as well as components of transmission towers. We would not immediately seek to lift the entire tower at once.
And just to follow up, so 3 units to do the work of 1 sky crane. What's the pricing difference? Like, how much does it cost for us to buy a sky crane? How much does it cost to manufacture 3 of these units?
We don't know for sure. We're mostly basing our estimates off of the known cost of human labor. We know that pilots are extremely, extremely expensive. And our goal would be to extend the useful operating life of our units in order to maximize their return relative to a human operated sky crane.
Thank you.
All right. If that's all from the judges, we will give you a couple of minutes to record your thoughts while we actually jump a little out of order to team 12, who has graciously decided to step in for another team that did not make it today. So team 12, floating multi-turbine catcher, please feel free to begin sharing your screen and prepare to present as the judges wrap up their thoughts.
Hello, can you hear?
I can hear you.
Okay, I'm just going to share.
Yep, just give us 1 second while the judges are finishing up and.
Oh, okay. Gotcha. So we just have to wait.
Okay. All right, team 12 from New Jersey Institute of Technology. Whenever you're ready.
Hello, everyone. How are you guys doing? My name is Alberto Camacho. I'm the head researcher of Powering Your Future. I just want to make myself known and introduce myself, as you'll probably be seeing my face and my designs in the future. But regardless, allow me to introduce our presenters, Michelle Hernandez and Fabronia Wild. Thank you very much for your time, and I'll see you guys in the next round. Thank you, guys.
Hello. So today we'll be introducing to you about multi-turbine floating offshore wind catcher. So what is this multi-turbine floating offshore wind catcher? It is a floating platform with multiple wind turbines that captures wind energy in deep waters. This platform reduces the need for expensive seabed construction, while the multi-turbine configuration increases efficiency and reduces the space requirements. This innovative solution offers a cost-effective, efficient, and sustainable source of renewable energy. And as we can see in the pictures, the size of one of these platforms is almost the size of the Eiffel Tower. Let me tell you a little bit more about the product description. So this device is built by a company based in Norway, and it's an offshore wind power generator producing renewable energy for 80,000 homes per unit at prices similar to the traditional fossil fuels. The structure could contain more than 126 rotors stacked vertically within the 300-meter high framework. The good thing about this is that smaller size turbines will make the product more efficient due to the fact that it produces much energy as 5 of the strongest floating turbines in existence, while cutting the price of the energy generated by 50%. Let's say at 17 meters per second, the wind has an energy of 13,000 watts per square meter. We have the top 5 benefits about this. One of them is it increased the energy generation, as I said before. This unit allows for access to stronger and more consistent wind resources, resulting in increased energy generation compared to traditional bottom-fixed offshore wind turbines. It improves scalability. This unit can be designed to support multiple wind turbines, as I said before, which can be easily added or removed as needed, making it more scalable than traditional bottom-fixed offshore wind turbines. Greater flexibility. The flooring design of the unit allows it to be installed in deeper waters, which opens up new areas for wind energy deployment and increases the flexibility of the technology. And also lowers the environmental impact. This unit minimizes the impact on the seafloor, reducing the environmental impact compared to traditional bottom-fixed offshore wind turbines. And lastly is ease of transportation and installation. The modular design of the unit makes it easier to transport and install compared to traditional bottom-fixed offshore wind turbines, reducing the cost and time associated with installation. So now Fabronia Wadi will continue with the presentation.
Okay, so the market opportunity for multi-turbine floating offshore wind catchers is driven by 4 key factors. First is a growing demand for renewable energy globally. Second, an expansion into deeper water provides new opportunities for wind energy generation. And third, the government, since it collects taxes, can help reduce the cost of building and operating wind catchers. Finally, as technology improves and economics of scale achieved, the cost of producing wind energy is expected to decrease, making energy more competitive with traditional energy sources. Now we're going to go talk about the business module. So first we have the market. The offshore wind energy market is growing fast, and the market for floating offshore wind energy system is still in its early stages, but it's expected to grow in the coming up years. This presents a significant opportunity for the company to meet the growing demand for renewable energy. Now for product and services, so wind catcher provides clean renewable energy in the form of electricity and is designed to build and operate by the company. It is designed and built to international standards and operated by experienced technicians. The company provides ongoing maintenance and repair services to ensure reliable operation. Additionally, the company provides training and supports to its customers. Next, we have the operations. So as I said earlier, the wind catcher is designed and built to international standards, ensuring high quality and reliability. It is operated by experienced technicians who ensures it's smooth in operation. The company provides ongoing maintenance and repair services to ensure the wind catcher's reliable operation. The company also provides training and support to customers, ensuring they understand how to use and maintain the system. Now for the financials, the cost of building and operating a wind catcher depends on the factors such as the size, location, materials, and labor costs. Financing can be secured through government grants, loans, and private investments. And revenue can be generated through the sale of electricity, carbon credits, renewable energy certificates, and other incentives. Okay, now for our business module for floating wind catcher. So first we have the value proposition to provide a novel and efficient solution for offshore wind energy. And then we have revenue streams. Main revenue stream expected to come from selling or leasing the technology to energy companies, governments. Can also include maintenance and repair services. Also, the cost structure includes research and development, manufacturing, marketing, sales, and installation, and ongoing maintenance cost. Now for the target market, includes energy companies and governments that are looking for cost-effective and efficient solutions, as we said earlier. Partnerships also helps to develop and test new technologies, secure funding, and expand market. And some key activities and resources include research and development, design, manufacturing, installation, and ongoing maintenance, as we also said earlier. Now for our conclusion. So as a multi-turbine floating offshore wind catcher provide a promising solution to meet the growing demand for renewable energy. They provide clean, renewable energies that can help reduce the dependence on fossil fuels and address the challenge of climate change. Whilst the market for flooding offshore wind energy system is still in its early stages, it's expected to grow in the coming years as technology improves and cost decreases. Companies offering multi-turbine flooding offshore wind catchers can provide clean energy to customers while generating revenue and creating value for shareholders. By following a well-designed business model, companies can secure financing, build and operate a wind catcher, and achieve positive cash flow. Overall, multi-turbine flooding offshore wind catchers offers sustainable and financially valuable solution for meeting the world's growing energy needs. And that's our work.
That was great.
All right. Thank you very much. I will now open it up to the judges for any questions.
Okay.
Go ahead, Michelle.
Thanks. Has this product been prototyped or commercialized in any way today?
It haven't been commercialized yet, but I know they have a patent for this.
So I'll ask my question. You said this is a 50% reduction in the price compared to a more conventional offshore large turbine. I didn't understand particularly why. It seems like the amount of hardware is approximately the same. You have multiple rotors and so on. Do you understand why that's a huge difference, 50%. I wanted to see why it works better.
Excuse me, could you repeat the question, please?
You'd suggested that this is 50% per unit of the cost of power generated this way is half of what it would be with a more conventional offshore wind tower. I didn't understand exactly why multi-turbines would be cheaper by that much. If it's just the company's claim, that's fine. I just didn't know where it came from.
So, my name is James Blasi, and to answer this question, the company does claim this, but however, it is true that for wind turbines, cost and production will scale by it's the cubic law. So the bigger turbine is going to be much more expensive than smaller one.
Thanks.
And as far as the business model, are you planning to manufacture these turbines or license the technology to another manufacturer, or do you want to be an operator, or do you want to license it?
I'm sorry, can you repeat the question again, please? Sorry about that.
Yeah. Are you planning to build turbines, or are you planning to be an operator or a servicer of the turbines, or just license the technology?
Oh, well, we're looking to be a servicer. This is a very big project that we don't think we could personally build, but definitely a servicer to a company.
Thanks.
All right. We'll now give the judges a couple of minutes to record their thoughts, and we'll ask that you stop screen sharing so we can allow team 5 to share their screen and prepare to pitch. Again, that's team 5, Li-ion Revolt from New Jersey Institute of Technology. Team 5, if you're here, we are ready to hear what you've got. All right, I am not sure if Team 5 is with us. Just double checking here. I don't see them with us here. All right. We may just go ahead on to Team 6 while we wait for Team 5 to join us. Or
Oh, I'm Team 6, sorry.
perfect. No, just you're doing exactly what I asked.
Okay, great.
So Team 6, blankets for your house from Columbia and Fordham. We'll have you present when you're ready.
Sure. Could you guys see my screen?
Yes, we can see your screen.
Okay, great. So we actually changed our name a little bit to Tarkification. And so, hello everyone. My name is Marco Roa-Sessa. I'm a biomedical engineering student at Columbia University. My teammate here in the Zoom call, he has his webcam on. His name is Ben Liang, and he's majoring in global business with a concentration in finance and fintech at Fordham University. Today, we will be presenting our business plan regarding a novel technology called TARC. So the following is our presentation agenda. What is TARC? Its implementation, market and consumers, issues and advantages, and finally, we'll be talking about the success of our proposed business. So what is TARC? TARC stands for Temperature Adaptive Radiative Coating, and it's a surface material developed by researchers at the Lawrence Berkeley National Laboratory. This surface coating technology is to be applied on roofs and or building envelopes to assist in year-round indoor household thermal regulation. It absorbs solar energy from the sun and emits thermal energy depending on outside temperatures. Essentially, it insulates heat during cold temperatures and cools during warm temperatures. So currently, researchers at the Lawrence Berkeley National Laboratory are scaling up the size of TARC, reaching meter-sized products and getting us closer and closer towards rooftop proportions. Most notably, studies by the lab have indicated that the average US household could save up to 10% on yearly electricity costs with the TARC installation. As opposed to electricity bills, TARC serves as a one-time fixed cost for the building, allowing for an even greater financial benefit in the long run. So who will use TARC? We aim to target three main portions of the market, including individual households, distributors, and small businesses. As for individual households, our most important target audience are them, as they will see the most obvious benefits from our product. They will be able to directly buy TARC from distributors for the option of self-installation. Small businesses can provide them with services to professionally install our product as well. So as for distributors, let's talk more about where individual homeowners can find their favorite TARC products. Look no further than large distributors such as Home Depot, Lowe's, Ace Hardware, and Amazon, where TARC products can be found online and in brick and mortar locations. These distributors will make up the majority of our sales as they will provide TARC to small businesses as well. For small businesses, we are mainly targeting construction companies and landlords. Construction companies can utilize our product to provide professional services in roof coating installment. Landlords can take advantage of TARC-coated rooftops to improve the promotion of their properties due to new possible reductions in electricity costs. We will offer wholesale bulk purchasing to small businesses. And so now I'll pass it on to my teammate, Ben Liang, for the rest of the presentation.
Thanks, Marco.
Thanks, Marco.
Let's
talk
about
the major market
players.
players.
Currently,
Currently, the following corporations dominate the outdoor roof surface coating industry for households. With the introduction of TARC, we would be a new competitor with product advantages that the rest don't have. These include solutions to modern roof coating in addition to TARC's thermal regulatory abilities, which we'll address. On average, a potential customer can spend up to $2.50 per square foot of roof coating material and up to $3 per square foot for labor. Considering an average roof size of 1,700 square meters, customers can expect a bill of up to $9,400 for roof coating alone. Now, let's address some of the issues of roof coating. First, installation is not simple and straightforward. Improper roof inspections or poor coating applications lead to common deterioration issues like blistering, chalking, or alligatoring. Next, roof coatings just aren't suitable with all roof materials, and some roof coatings only work on flat roofs. Thirdly, roof coatings are not the most durable option out there, and they're prone to tearing from forces like hail, abrasion, and foot traffic. One major benefit of TARC is that it's mechanically flexible, and it makes it suitable for roofs of all shapes and sizes. It's also been proven to outperform existing coatings in savings. In most climates, especially those with big temperature variations, from day to night, like San Francisco, or between like seasonal variations, like New York City. Last but not least, TARC automatically turns off its cooling technology when it's cold, which increases energy savings. Large-scale production of TARC will require factories with vanadium dioxide, which is the great majority of TARC's makeup. The price of production will correspond to our selling price, which will optimally be less than $10,900 per each average rooftop. $9,400 is spent on roof coating installation, and $1,500 can be saved from 10% of electricity bills for 8 years, which is the average length we're using for home ownership. As for our product's overall benefits, homeowners can save money in the long term through energy savings and unnecessary roof coating maintenance. Small businesses will have new services to provide to their customers, enabling them to grow their revenue. Distributors can increase their sales due to introduction of a new product as well. TARC allows for reduced energy expenditure in households, meaning less spendings on heating and cooling systems. We'll be able to significantly reduce greenhouse gas emissions since large-scale TARC installations across the country add up. We define success for TARC through the access for local small businesses. By this, we mean our ability to supply local construction companies in the tri-state area with our product for their new services. At the same time, I have a goal of partnering with one major distributor serves as a milestone in what we define as success as well. Aside from the business aspect, we ultimately hope TARC will contribute to an ongoing pursuit for a more energy efficient society and inspire more developments in the near future. That's all we have for right now. We're excited to answer any questions you have, and thank you so much for your time.
All right, thank you very much. We will now have the judges ask their questions.
Is this an underlayment or is this the final coating on the roof?
So this would be used as the final coating on the roof because it needs to be exposed to the or visible to the sun in the most like direct form or passage to use that absorption to emit corresponding necessary amounts of thermal energy regarding to how hot or cold it is outside.
So would it be applied over existing asphalt shingles on residential roofs?
So as for the application of TARC on roofs, it could serve as an alternative, but also being as an alternative to roof coatings. But to be put on top of asphalt is also definitely doable, since they are going to be in these sheet-like patterns. They're not necessarily like a paint that we might come across with surface coating, roof coatings. And so by having them in sheets in a more solid form, they're less susceptible to breaks or alligatoring that we talked about before, in which reinstallation of a roof coating would be needed. Yeah.
So, real quick, the finished look is a sheet of this material that's applied. So it's a sheet good. It's not a coating.
Yes. So the finished material would be the sheet material. Although I did say it's a sheet material, it is very malleable and very flexible to the point that it could be seen as coating. It was referenced as a coating material on the National Berkeley website. But it isn't paint-like that we might see for the surface coating materials that we use today.
So to follow on, if I were to give you 3 options of what this product is it a spray coating, a film coating, or a new tile with the material on top?
It would be more so of a film coating.
Okay.
Just a quick question. Isn't vanadium expensive?
So yes, we did look into the cost of vanadium dioxide if one was to purchase it directly from a sort of chemical source. And it does seem to be very expensive, but looking at the Berkeley's lab website, they showed promise in energy savings, but also financial efficiency in using it for surface coatings. To that extent, we're not entirely sure because the technology is currently ongoing and the patent is actually also ongoing. But so to know the exact number is a bit difficult, but they do show promise in electricity bills, efficiency or savings.
Well, I understand if it works. I was just curious about the raw materials cost. It's not a material I hear suggested for widespread use very often. So that's
no, yeah, for sure. It's definitely no doubt that vanadium is definitely on the pricier end. But I think it serves more as a fixed cost that over time might prove to be beneficial in the long term.
All right. Thank you, judges, for your questions. We'll give you a couple of minutes to record your thoughts while we jump back to team 5, who I believe is now ready to present. If they would share screen.
Yeah, I'll start sharing my screen right now.
Perfect. All right. Just give us a couple of minutes and we'll be ready to hear what you've got.
Okay, just let me know.
Okay. If the judges are ready, we will now hear from team 5.
Okay, so my name is Michael Delangelo, and this project is called Li-ion Revolt. So basically, this is a process that's meant to make the process of developing new lithium-ion batteries less expensive and make them more accessible to companies using newly developed research methods. So there is a demand for new practical uses of lithium-ion recycling. So a new form of recycling just recently discovered can extract cobalt and other valuable components from lithium-ion battery electrodes at room temperature with less temperatures and shorter reaction times using less reducing agents. And these reducing agents are also less toxic to the environment. So they would be incentivized for using these. And this is done by selectively stripping cobalt using sulfuric acid. Just for some context, the old method of getting these metals was just to produce them entirely separately in a separate process instead of recycling them from the same materials, which is the most widespread use of development today. And basically, it combines solvent leaching with solvent extraction, which is basically saying it's not a metallurgical process used to get these metals out. So this process brings the production of these batteries to a smaller circle, obviously. In the journal Green Chemistry, the sulfuric acid it was directly loaded onto the organic building phase. It was assisted by copper that reduced cobalt-3 and lithium cobalt oxide to the more soluble cobalt-2. And just in this real world today, we can see that the ongoing surge of electric vehicles in the near future will result in an unprecedented amount of lithium waste. So these batteries are being consumed more and more in daily life. So recycling them will become more crucial. The market for these batteries is very large. Some companies have a larger share than others. I'm sure you've heard of Tesla, Jaguar, Ford, other companies entering the electric vehicle market. It's growing and growing. But following that, the costs associated with transporting these batteries is very great. You have to follow many protocols and standards just to produce them and transport them, which have costs in and of themselves. Standards made by countries. If you're in a foreign country, they're going to have their own set of protocols used for transporting, costs associated with that. So this new means of production will reduce those costs by making the manufacturers produce more per production unit. So an increased supply of these batteries is going to lead to lower fixed costs for the manufacturers due to less costs on capital goods. So you can see here just the market share for lithium-ion batteries globally, not just in the US. You can see it's not just electric vehicles that's driving the cost for the increased production of these batteries, just household electronics and energy storage itself. It's a very large market. You can see here, this is just a year-over-year trailing graph of the demand for these batteries. 2016, it's projected 3 years ahead of now, you can see. So it says here, CE shipment. That's actually just the costs associated with following protocols. So that's a fixed cost. You have to follow these standards to make sure the batteries are safe. So you can see a large amount of demand is just constantly increasing, just year over year. And you can see, again, diversified. If you have concerns about the market not continuing to grow, and GWH, that's a gigawatt hour, you can see just vehicle storage and household electronics are driving the cost of these batteries. So for some comparison, according to data from Bloomberg, each cell's cathode in lithium-ion batteries half the overall cell cost, meaning that the valuable metals in the battery are more costly than the productions of producing them themselves. So historically, it costs around $200 per kilowatt hour historically in the past 10 years. And this new solvent strategy that's just been discovered will retrieve these precious metals, lithium iron phosphate, lithium nickel manganese cobalt, and lithium nickel cobalt aluminum oxide. This is going to drive the cost down substantially. So an increase of capital goods to salvage a greater amount of these materials and these valuable metals will drive down the variable costs associated with producing each and every lithium ion battery. That's because these cathodes make up more than half of the production cost. You can see here in the bottom right, just the materials, raw materials themselves are more than half of the cost for each battery. So this new solvent that's just been discovered actually in 2022, I have in my references by Green Chemistry Journal. This is a very new solvent, uses sulfuric acid. It's going to cut down on a lot of these costs to produce these batteries in terms of materials. It's not settled science. This is very new. So any companies jumping into this right now going to have a head start. You know, I haven't heard this talked about in daily, like household talking, but lithium ion batteries dominate our daily lives. whether you see it or not. These are going to drive the cost down. So based on historical capital goods investment data, we estimate it'll take about, for each production firm, about 1.4 million for each plant to incorporate this new method, which is just basically a separate plant that recycles these metals. That's on historically what a machine of that type would cost to make. But the variable cost for each battery will pay itself off. You can estimate around 15,000 battery production units when you're saving that much percentage on each battery being made. And you can see here, this is just a graphic showing the valuable metals taking up more than half of the cost for each lithium-ion battery. And this is the old, or the traditional circle for producing batteries. And we're claiming that this new sulfuric acid method is going to make this circle smaller. You can see from metal extraction and metal refining, that's worth around $200 per unit. As you just saw, the total cost is around, $275. So bringing that cost down is going to make these batteries more accessible, and it's definitely worth to invest in these new capital goods. This is just dollars plotted against kilowatt hours capacity, or watt hours. You can see it's going down gradually, so there's not much skepticism surrounding these new methods that are constantly being discovered. And these are the references. I'm open to any questions. My group members, actually, they don't happen to be here right now, so I'll answer any questions you have.
All right, thank you very much. Judges, any questions?
Is this a proprietary chemistry, or is it open to anybody to use this?
The materials themselves are open to use, obviously, but they haven't been doing it. It's accessible. It's gonna, this study published in 2022, sulfuric acid, that's a very widespread chemical, but the new way that it's being used is not very widespread, and it's not well known. And I believe sometime in January of this year, just the first firm, maybe it was Jaguar, built one of these firms. So this is very new stuff.
This sounds like a pretty interesting plan, but how would you propose to get into this business?
So basically what we propose to do is have our research down for how the sulfuric acid specifically can be used, because like we said, it's just studies. This isn't Tesla already doing it, and we're trying to get our hand in it. So I have on my team, I'm a business major, I have on my team 3 electrical engineers. I'm actually nothing to do with electrical engineering. So I would say the way that you get into this business is, you get your patents, your copyrights for how this can be used. You invest, you have your own personal brand of, your industrial copyrights for what's going to be used in the firms. That technology is sold to these manufacturing firms. So that's how it would be profitable, I guess, from that standpoint.
So following on to Eric's question, are you wanting to be a recycler, or you want to patent your process of leaching these metals out and patenting that process and licensing the technology?
Licensing the technology. It's very, it being very eco-friendly and sustainable. That's just a great selling point of the process itself. But that also does happen to drive the costs down because of the metals that are being discussed also.
All right, if that's all from the judges, we will give you a couple of minutes to record your thoughts while we allow Team 7 Fluorocell high capacity batteries from Rutgers to share their slides with us. Team 5, thank you or Team 6, or yeah, Team 5, sorry.
Yeah, thank you for your time.
Yes, thank you. You can stop sharing with us. Thank you.
Cool.
Okay, so thank you.
Sorry, just give us 1 second while we're just
Sorry about that.
allowing the judges to wrap up.
My bad.
I love the enthusiasm.
I don't like the awkward silence.
All right, they look like they might be ready to go now. So go ahead. Thank you.
Okay, so welcome to Fluorocell. Thank you for listening to our presentation. The deep freeze in Texas, the blackouts in California, Ohio, Nevada, and so many more have been plaguing our grid infrastructure for a long time now. And that's just a testament to how unresilient our grid infrastructure is. Now, if you look at this map here, the congestion is also at an all-time high, and the costs of this congestion is insurmountable. I mean, it costs us $6 billion annually, and almost 5% of all electricity produced annually. So to put this into perspective, that's enough electricity to power all of Central America for a good month at least. Now, so that takes us to two definitive problems. One, grid resilience, especially to extreme weather occurrences, and grid congestion.
So this is where we come in. Our battery technology shows promising energy and power capacity to help solve grid congestion problems and grid resilience. So we are basing our technology on the IPs that are owned by Rutgers, which are available to license. These technologies were invented by Dr. Glenn Amatucci from Rutgers University. This technology uses novel fluoride compounds as electrode materials, mainly cathode, and they provide excellent rechargeability and minimal degradation. Now, the main reason this technology stands out from current lithium-ion chemistries is because of its, again, as I mentioned before, energy density and power density. So now during the charging and the discharging process, conventional lithium-ion batteries, they go under intercalation reaction, where per reaction, there is a transfer of an electron and lithium ion. Now, our batteries, when they go under this intercalation process, because of the the fluoride compounds that we are using, we can transfer about 3 electrons and 3 lithium ions per reaction. So this makes our battery hold about 200% more energy by mass and 300% more volumetric energy compared to conventional lithium-ion batteries. Now, historically, energy storage systems they were considered very expensive. So on the left, according to Bloomberg report, the price of energy storage system has been declining due to the advancement in science and technology. Now, currently, they are reaching at a plateau. Now, we see that in past 2 years, we see that there is about 7% increase in the price, and this is mainly because of supply chain issues of depleted resources like cobalt and nickel. Now, with our battery composition, we will bring down these prices significantly as we will be able to store more energy in our batteries. Now, on the right is a plot of various generators that are queued up to increase the energy capacity. Now, here we see that the demand of energy storage system is increasing exponentially in this market.
So now that brings us to our target markets. Now, for our first and main target market, we have generator operators who can use our batteries for energy storage and flexibility. We also have transmission owners to offload energy from the grid into the batteries while at peak congestion times, as well as utilities who can buy energy at cheap prices off peak hours and sell them at high prices at peak hours. Now, to go into our business timeline, we plan to use university funding, SBIR funding, prize money from competitions like this to start building prototypes and testing, as well as doing market research for further market research for pricing. And we also continue to use that funding to scale up manufacturing, look for manufacturing partners, whether it's a local or big manufacturing partners. And then we would look for further angel investors, venture capitalists, to expand our beta testing at existing grid scale solar farms and other power plants. And finally, for our commercialization, we would most likely partner with existing large scale solar and wind developers or other potential power plants to implement this solution. Now, to reiterate, our value proposition is based off of the solutions to two main problems: grid congestion and grid resiliency. Now, as I've said before, the grid congestion problem would be solved or helped by providing battery stations across congestion points for transmission owners to offload the energy into, as well as for resilience, generator operators can prevent that overloading, as well as store their excess energy so they make sure that they don't continue to overload the transmission lines. Now, this is our team. Also unlisted here is our advisory board, which consists of the inventor, Glenn Amatucci, and Dr. Jeffrey Robinson. Thank you. We will be taking questions now.
Thank you very much. Judges, any questions?
I'll chime in. So let's see, it took over 20 years to bring lithium ion batteries to their present state, and enormous sums of money. This seems to me to be similar to the way lithium ion batteries were more than 2 decades ago. So what is the opportunity to make this happen faster, or a lot of technological hurdles for lithium ion batteries, for example?
So luckily for us, technology is a lot more advanced, especially manufacturing technology. And we can utilize those advancements in technology and whatever we've learned from existing lithium ion manufacturing scale-ups to apply to our current chemistries, as well as easier sourcing of materials, because we wouldn't have to, we're not subject to the same supply chain constraints as current lithium ion chemistries with cobalt and nickel.
So is the removal of cobalt the key thing here?
Yeah, and so the removal and replacement of cobalt and nickel.
Okay.
I'm not sure if I missed it, but why focus on grid connected solutions and not consumer battery tech?
So that is a place where we could have focused on. If you go back to, actually, I don't remember the slide, but 2 slides after the future of battery technology one, our biggest advancement with this chemistry is the 300% increase in volumetric and energy density rather than gravimetric energy density. And while gravimetric energy density would be more helpful for consumer applications such as electric vehicles, grid storage would more benefit from the volumetric energy density. And that's where we think we have the most impact.
Thanks.
And if I can add to your question, that currently we are paying the price we are paying for electricity is much higher than we should be. Should be technically paying low, but because of the congestion, the prices that we are paying right now is going up. So reducing that congestion would also lower down our electricity bill. It would be also help consumers.
So do you see yourselves as more of a peak load shaving kind of thing? or
Sorry, could you repeat that?
higher prices happen when highest peak energy demand happens and you're offloading some of that to storage. Is that you consider yourselves saving on in that end rather than cost savings to the utility?
Yes. And we want to improve, reduce the variability of the grid by doing that.
All right, thank you very much. We will now allow the judges to record their scores and thoughts while we allow Team 8 to prepare their slides. Team 8, efficiency boosting thin films for solar panels from New York University.
Okay, can you hear me?
Yes, just give us a couple of minutes while we let the judges wrap up writing their thoughts.
No problem.
All right, if our judges are ready, we will hear from Team 8.
All right, so hi everyone, we are Heliotrope and we make efficiency boosting films for solar panels. Solar is an important technology to help curb carbon emissions and limit the effects of climate change, and we need the cost of solar to drop to spur dramatic adoption. Costs have decreased dramatically in the past decade, but still need to decrease further to be cost competitive with fossil fuels. And one key way to lower cost to consumer is to increase efficiency, to get more power out of each panel. Higher efficiencies lead to lower cost of electricity for consumers, but they also create more value for solar manufacturers. Solar manufacturers sell in units of power in dollars per watt, not necessarily per panel. So a more efficient panel is also a more valuable panel, and companies are scrambling for ways to improve efficiency. Solar researchers have developed some amazing technologies shown in this plot of champion research cell efficiencies over the past few decades. However, even as lab efficiencies have skyrocketed, the maximum efficiency of silicon solar panels on the market has only improved by a few percent in the past 20 years, and many panels remain well below those maximums. So there's a gap between research developments and market implementation that's largely due to the complexity of the devices, non-scalable processes that don't survive the jump to manufacturing, and high costs. Manufacturers have limited options to increase efficiency, especially after they've already set up their factories. So we set out to design a cheap and easy way for solar manufacturers to increase the efficiency of their existing technology. Our solution is that we change sunlight, not the panel. We convert wasted and damaging ultraviolet light into useful and safe near-infrared light, and thereby increase the efficiency of the underlying solar panel. Our solution is a drop-in technology. It's applied to the glass layer and does not alter the underlying cell. It was designed with manufacturing in mind, using established processes in the industry, which will make it easier to scale up. And we know that manufacturers are sensitive to regulations and policies that are coming soon, so our solution is lead-free for safety and easier recycling. And by reducing UV exposure, we will lead to increased lifespan of the panel. Let's look more in depth at how increased efficiency leads to increased panel value for our target customer, the solar panel manufacturers. Increased efficiency leads to a higher energy output. Each panel produces more electricity and thus more value. Additionally, there's an efficiency premium. More efficient panels have a higher market value. This all leads to a 25 to 30% increase in the panel dollar value. This is a little bit abstract, so let's look at an example. Imagine we have a panel that's 20% efficiency, 300 watts, and the market price is $0.3 per watt. That panel is worth $90. If we add our film, we get an efficiency boost, which also boosts the wattage, and the price per watt also increases. So this panel is now worth $115, about a 25% increase. So those are the benefits. What about the costs? Our value proposition is that for a 1 to 2% increase in the manufacturing cost, we can produce a 25 to 30% increase in the panel dollar value. So here's where we are right now. We've developed proof of concept films, written academic papers, and filed provisional patents. And now we're moving to bring our technology out of the lab and into the market. Our current technology is what we call a one-to-one film. What that means is that one ultraviolet photon coming in gets converted to one infrared photon. This technology will work best with panels that are not as efficient in ultraviolet, specifically silicon heterojunction panels, and they can provide an 8% boost in efficiency. It's worth noting that the silicon heterojunction technology is a smaller but growing sector in the silicon solar market. It is estimated to be nearly 10% of the silicon panel market in 2024, which is around 100 million panels, and it's projected to grow to 20% in 2032. So this will be our initial market. We're also developing a 1-to-2 conversion technology in which one ultraviolet photon is converted into 2 infrared photons, dramatically increasing the efficiency gain. This technology will work with both heterojunction and PERC solar cells, which combined make up around 90% of the total solar market, and we can provide a 16% efficiency boost. So this future market comprises around 1 billion solar panels and is growing at a compound annual growth rate around 8%. So to recap our business model, we're a B2B. Our target customer is silicon solar panel manufacturers with a strategy to license our thin film technologies. Our initial market will be silicon heterojunction, and we plan to expand in the future to silicon heterojunction and PERC cells. And here's how we make money. Without our film, a manufacturer would have a profit of $10 in this scenario. Their manufacturing costs are $80 and they can sell the panel for $90. Adding our film only increases the manufacturing cost by $2, but triples the available profit. That will need to get split between us and the manufacturer. So let's just assume that we get $5 and they get $28. They spend a few dollars to nearly triple their profit. When we extrapolate that into the market at $5 per film, we have a total available market of $5 billion. So these are some big numbers and big questions around the size of the market, but gives us a ballpark of where we are. We do have some competitors, in particular tandem cells, which are essentially stacked solar cells, offer strong efficiency gains, but they have a complex device structure and are difficult to manufacture. And because of those reasons, they tend to be more expensive than our solution, and they often contain toxic materials. There's other light shifting materials that offer efficiency gains and have a simple device structure like us. They've struggled to scale up their manufacturing processes or take their processes from the lab to manufacturing, and they also contain lead. So our technology solves all of those issues. And here's a look at our roadmap. So where we are right now, we currently have a 1-to-1 film proof of concept. We will work to develop the 1-to-2 film as well as validate the film performance in the next year. We would then move into a pre-pilot phase where we scale up to a wafer or cell size and develop recipes for inline coating, looking ahead at larger manufacturing. From there, we can move into a pilot test phase at full module size, likely with partnerships from solar manufacturers, and develop robust operations, and finally move into a licensing for a large scale production. To summarize, our potential impacts are that for solar manufacturers, we can produce higher efficiency panels for greater profits. And for consumers, we can decrease the cost of electricity, with the goal that we ultimately drive solar adoption and increase our solar capacity to accelerate the transition to a sustainable world. And with that, just like to comment on our team. So it's me, my co-founder, Min Tran, and our advisor at NYU, Professor E-Ray Idle. We're all working in sustainable engineering and solar materials. And with that, I will be happy to take any questions.
Thank you very much. Judges, we will now allow you some time to ask questions.
Can you go back to your competition slide?
Absolutely.
So you said that one of the main competitive advantages you have right now is that you are more able to scale manufacturing to larger size from lab scale to market scale. Is that true? You have market scale technology?
Yeah, so we use physical vapor deposition right now, and there are machines. We're talking to companies that have machines to deposit in a very similar way. So there will be questions there and things we need to solve. But compared to some drop casting methods or more liquid solution methods that people are using to make these materials, our lab technology is very similar to the industrial technology. But there'll be kinks to work out as we move there. But the machines exist, the technology exists.
Sure, but you still are at that. You have that same problem that they do, that scaling to the manufacturing level. You haven't created like a sheet 3 feet long, right?
We have not, but we can using the same technology. So the way they made their films does not scale. Like there are no machines that make it at that size. We have options.
Are you planning to do like roll to roll?
No, the idea would be to sheet an entire to coat an entire sheet of glass.
I see. Got it. Thanks.
I'll just ask, so what's the difference between your light shifting technology, the one-to-one, and the blue dot one?
So
besides these practical issues, what is
yeah, no, absolutely. So they have a 2-to-1 or 1-to-2. So they have what they call quantum cutting. So they have developed that technology, but they use lead, and they've been having, like I said, difficulty scaling up and proving out that efficiency gain. So it would be a direct competitor with theirs if we can develop the 1-to-2.
Okay.
You may have mentioned this in the beginning, but this can be applied to any type of solar panel, correct?
Correct. It can be applied to any type of solar panel, but it won't affect its architecture, but it will be most effective, especially in the 1-to-1 with panels that suffer in how they convert UV to infrared or UV to energy. So here, let me pull up this slide right here. So this blue line is the quantum efficiency of a solar panel. So it's how well it converts a photon of a particular wavelength into electricity. And you see there's a drop off in the UV for many panels, but that's not true for every panel. So PERC cells do okay in the ultraviolet. So we don't think that we can target that until we reach this 1-to-2 technology.
I imagine you're targeting the manufacturer of the solar panel before the consumer to try to get that, or?
Yeah, correct. I mean, definitely we are looking at panel manufacturers.
Great, thanks.
So you're planning to license this to manufacturers, I would assume, in China, since that's where most of them are. Do you have any, you filed some provisionals. Have you filed internationals?
No, so we're working with NYU right now on the IP and beginning to talk with solar companies and thinking about that international competition.
All right, thank you very much. We'll now allow the judges some time to record their thoughts. And after those 2 minutes, we will actually take an extended 4-minute break so that everyone can kind of stretch a little bit before we get on with the second half of today's competition. All right.
All right, do we have a minute? All right.
Yes. So we'll take 4 minutes now to allow you guys to move around a little bit. All right. It is 2:55. If everyone can join us again, great. In a minute here, we'll be hearing from Team 9, HVAC Capture, direct air capture on an HVAC system from Columbia. So if Team 9 is here, we'll ask that you share your screen now.
Great. All right, ready?
Yes, all right, we see your screen. I'm going to assume that everyone's here with us. All right, so you can begin whenever you're ready.
Great, thank you. So my name is Anthony Thompson, and I'm presenting on behalf of the HVAC Direct Air Capture Group on behalf of Columbia University. So what we're ultimately proposing is putting a direct air capture system directly into the exhaust of an existing HVAC system. So what we're proposing will be both the coils or the carbon capture system, as well as the services provided in order to analyze the system. So what ends up happening is you take the return air from a system, put it into the exhaust, pull out the CO2, capture it, and then return that air directly back into the space rather than pulling in outdoor ventilation air. So our goal today is going to be to take your breath away and then show that we can capture it and then sell it for a profit. In this presentation, we're going to show basically how the system works. We're going to discuss what the energy is that's involved in it. We're going to talk about the motivation for why you would want to do it. And then we'll get into the CO2 savings as well as the economic payback of it. So getting into an overview of the system, why we're ultimately doing this is because buildings are switching over more and more to all electric designs, and there's a looming cold crunch. So what that means is that the building loads are ultimately going to increase as extreme weather events become more and more common. The other goal is markets like New York City, they're putting on carbon capture or putting on carbon emissions limits on different buildings. So the motivation here is that it's a way for you to reduce your carbon emissions by directly capturing from the HVAC system, as well as reducing the ventilation loads from the outside. So how we determine what ventilation loads we're saving, which is really where the energy savings are coming from. So what we end up using is ASHRAE 62.1 2016, which is the latest ventilation and indoor air quality guideline given by ASHRAE. So what this describes is basically how you determine the amount of ventilation air, and from there we can deduce the amount of energy that we're saving using the system. So let's discuss what the system is. Basically what we're doing is putting in a sorbent carbon capture system using zeolite. So what is a sorbent? A sorbent is a solid carbon capture system that could go directly into a filter and be put into the exhaust airstream. So this is very similar to a MERV filter or a HEPA filter. And basically after a year or some designated amount of time, you would pull out this filter, pull out the zeolite, regenerate it, pull out the CO2, and then put it back into the system for continued use. And then why do we choose zeolite? For two reasons. First is that it's basically the base case. There are other options that are much more effective and also more cost-friendly. So this provides basically the lowest analysis to show that it's economically feasible today. And the second is that the market is comfortable with zeolite. And the reason is it was invented really in the 1950s as part of NASA, so that space shuttles, the International Space Station, can have occupants without breathing in reuse CO2. So we already have an understanding that the system is effective and can be used on large scale for people in an occupied space. Here's an overview of the system boundary for traditional and the proposed case, and then I'll get into the system model. So some of the assumptions that we're making, the most important is that there's going to be a CO2 pipeline grid that exists in the future, and that the grid is going to trend towards net zero by 2050. So first we determine the mass of the CO2 that must be removed from the zone per New York City Construction Code, ASHRAE 62.1 2016. This code defines the amount of ventilation air that needs to be provided and exhausted as a function of space type, occupant density, and zone area. A science lab, for example, is 1.33 CFM per square foot at peak. Then, using the difference in CO2 concentrations between indoor and outdoor air, we deduced a peak of 9.2 grams of CO2 removed per square foot and about 40 kilograms of CO2 per square foot annually. With a known ventilation rate, we conducted a peak load calc for the typical HVAC case to provide air at room neutral conditions. Heating and cooling sensible energy can be solved using Q equals MC delta T, which is reduced to a function of volumetric flow rate and difference in temperature. Dehumidification energy is the summation of sensible and latent energy, which is a function of difference in enthalpy. So in summary, this is how we determine the amount of energy it takes to condition the ventilation air that now will not be needed using the direct air capture system. Next, through an annual load calc, we determine both the peak and annual loads. This study can be extrapolated to any different space type shown, with the science lab being an excellent example. Loads are multiplied by the efficiency of the HVAC unit to calculate the electricity input. Here we compare the energy required to remove an equivalent mass of CO2 between traditional and carbon capture systems. We see a significant reduction in both peak and annual energy consumption, showing technological feasibility today. This table shows the sequestered carbon from the embodied carbon, so that we compare this with the operational carbon to see what the total payback is over time. The following graph shows that the proposed carbon capture system has both a lower embodied carbon output and a net annual carbon savings. Therefore, after 6 years, the carbon capture system becomes a net carbon capture device, while the traditional system continues to emit carbon. And now we'll get into an economic conclusion. We predict now that by 2028, in the New York City market, the economic payback will be viable within 5 years. If you start to expand to other regions that are a little bit colder, such as Boston or even Canada, it becomes much more viable. And the reason is the ventilation rates to condition cold outdoor air becomes even higher, which means that these buildings would be economically feasible for this implementation today. The next building that would be very interested in this are those that are affected by carbon cap limits, especially those that are already emitting carbon. For example, using Local Law 97, any building that emits CO2 from fossil fuels cannot purchase renewable energy credits to offset those emissions. This system would provide an option for those buildings to offset emissions. And then finally, this is going to be ideal for systems that utilize cogen. These systems, for example, are soon to become stranded assets that they've been recently invested in, but no longer are viable as they emit carbon. However, when paired with CO2 capture, they become feasible. However, the cost is often prohibitive. If you compare that cost with the cost of this system and you combine the two, then the first cost gets reduced and the utilization factor increases. So ultimately, we see economic feasibility today and technological feasibility today. Thank you. That's the end of our presentation.
Thank you very much. I will now open the floor to the judges if they have any questions.
So can you explain, is this a filter that's put on the system, or is it something that's applied to the return coils, or what is the actual technology, and how are you selling it and who are you selling it through to?
So it's essentially a filter, yes, that gets placed into the exhaust airstream. So you would place it basically before the HEPA or a MER filter, and this way you're reducing ultimately the amount of airflow that goes through those filters, which reduce the pressure drop. But also it provides you the option to provide it right into buildings that are already existing. The space that it takes up is very minimal. It's really about the surface area. So it is essentially a filter that slides right into the return air handler.
Okay, so none of the equipment needs to be retrofitted to accept this.
Correct, right.
So this would go on existing air filters.
The goal is for both. You could put it very easily in proposed design, but our market that we see today is really buildings that are already emitting Local Law 97 that need a way to get the extra step. So making it feasible for existing construction is definitely the priority.
I may have misunderstood here. The carbon dioxide you're talking about comes from breathing?
Yeah, so what we're talking about here is basically the CO2 that's emitted as part of the ventilation requirements from ASHRAE 62.1. So just taking an example for a science lab, because those are going to be systems in New York City that are going to take a huge penalty. The requirements are 1.33 CFM at peak of outdoor air. So really, we're pulling out the carbon capture from that system. We're pulling out the CO2 from your breath. And the motivation is one, to capture that CO2, but really it's to regenerate the air and make it fresh again so that you don't have to pull in outdoor ventilation air. But yes, we're capturing CO2 from your breath.
Well, how would this compare with energy recovery ventilation, which is already a prominent technology in science labs?
That's right. Heat pump chillers, for example, are a great example. However, they do not allow you to not pull in outdoor ventilation air. What that does is recover air from your exhaust and put it back into your incoming air. There's no reason why you couldn't pair these two systems together. You could still do energy recovery, air side, water side with this. All it's doing is reducing your ventilation rates. So in reality, it's more of a competitor to demand control ventilation, for example.
Okay.
And did I miss who your customer is, who you're selling this to?
So I think our biggest customers would be building owners that are in cold weather climates, or those that are affected by looming carbon capture limits. So building owners in New York City, building owners in Boston, building owners in the Northeast in general, or colder climates.
So you're going to manufacture these filters rather than sell it to an existing, license the technology to existing filter manufacturers or HVAC equipment?
I think it would make the most sense to work with a manufacturer to create the filters and then focus more on the engineering design and finding the opportunities. So it would really be pairing the filter production with the engineering design aspect.
All right, thank you very much. We're going to ask that you stop screen sharing so we can allow Team 10 Grid Discover from Stevens Institute of Technology to present for us in just a couple of minutes as we allow the judges to record their scores and impressions. Thank you.
Thank you.
So again, that's Team 10 Grid Discover. Feel free to share your screen. Oh, perfect. All right, and we'll get started here in just a couple of minutes. Oh, just a minute or so, actually, as we allow the judges to wrap up. All right, Team 10, take it away.
Awesome. Can you guys hear me?
Yes.
All right, fantastic. Here we go. I believe we have everyone else here. Good. All right. Welcome and thank you for having us. We are Grid Discovery and we are on a mission to simplify microgrid planning using data. Let's go ahead and dive in. Microgrids are small power grids that offer a resilient source of energy, even during widespread outages. Their popularity and adoption are experiencing a remarkable surge across the country. Our goal at Grid Discovery is to streamline the microgrid value chain with intelligent and cloud-based solutions. Think of us like Zillow, but for the microgrid industry. The microgrid industry is experiencing growth mainly for three reasons. The first one is the need for resilience. The US power grid is growing old and outages cost businesses millions per year. The second reason is economics. Federal and state incentives are creating an attractive environment for project return on investment. And third is sustainability. Climate change is putting pressure on businesses to adopt better and more resilient practices. So what's the problem? Proper tools are not easily available, leaving consumers to break through a hard barrier to entry for the industry. The problem is that determining if a microgrid is right for you can be an incredibly long and technical and messy process. This process is referred to as a feasibility study. So let's examine some issues with the feasibility study. First, the process is very technical and requires access to complex tools. The second is that it is a very long process involving many stakeholders that can take months to complete. And third, it is expensive. This sometimes leaves smaller communities relying on grants and loans to fund the study. I'd like to pass it off to one of our software engineers, Jason. He will be talking about the solution.
Thank you, Omar. So Grid Discovery aims to change that by offering users a simple tool to help them better envision future microgrid projects. By layering key data points over rich geospatial maps, Grid Discovery provides a truly turnkey solution to microgrid planning. Here's how it works. First, we start by intelligently combining publicly available data. This data is often siloed, like building energy consumption, power outages, and local climate hazards. Next, our algorithm processes this data to extract useful insights to inform and guide users through the project analysis process. For example, if a building of interest is energy inefficient, our tool will inform users of potential reasons for it and provide recommendations of potential alternatives. Our current target audience is municipalities and property owners. These groups are highly motivated to pursue climate resilience, but oftentimes lack the microgrid expertise necessary to get started. Through conversations with engineering firms, we are confident that Grid Discovery can also serve as a lead generation tool for project adoption. Grid Discovery will assist in the clean energy transition by lowering the barrier to entry for microgrid projects. By simplifying the initial microgrid analysis process, we are helping create a more informed and engaged customer, thus increasing microgrid adoption rates across the country. Now I'll hand over the presentation to our fellow engineer, Walker, to discuss the business logistics of our technology.
All right, thank you, my man. Grid Discovery is a result of collaboration between students in Institute of Technology, 5 students on the left, and industry experts, the 2 handsome gentlemen on the right. We have the passion, experience, and network to take this academic-inspired technology and turn it into a commercialized product. Not only can this tool help users of all experience levels make more informed decisions, we can help engineers streamline projects and offer lead generation opportunities as well, leading to increased project adoption and ultimately a more engaged consumer. Grid Discovery is on a mission to make information simple and accessible. This is why we'll offer the tool as a software as a service, or SaaS, I'm more familiar with the term. Users will be able to get started for free without having to deal with any sales teams or clunky demos. You know, who likes those, right? And can then upgrade their they can upgrade their subscription based on their project needs. We're also exploring a market in which Grid Discovery will connect interested clients with carefully vetted engineers. Now, as we mentioned before, the microgrid industry is growing substantially. Research estimates the global industry will be valued at approximately $61 billion by 2027, with North America capturing about 40% of that. That's a lot of money, right? With our expansive business model, we estimate that we can capture about 1 billion market share, and thus positioning Grid Discovery as an industry leader and the go-to for anyone considering a microgrid project. Thank you, thank you. We appreciate you guys taking the time to listen to us. Now, does anybody have any questions?
All right, thank you very much, Team 9. We will now open for any judges to ask questions.
I guess I'll start. Oh, go ahead, Eric.
I just was curious about the uniqueness of your software. How many competitors do you already have? You're not the first outfit that I've heard of that is interested in this software.
Sure. We have a few competitors who focus more on project design, like how will the actual microgrid interact with the building electrical components, like Kavala, Zendi, and GridMarket. However, they understand the potential of project discovery like us and are therefore trying to get into the space. If you're looking for more uniqueness, you can kind of think of us more looking at the statistical and quantitative approach to that we have at Grid Discovery. We look at buildings as numbers, while other companies look at them as components in a project. This allows us to integrate different statistics and data sets to build a complete model packed with alerts and recommendations.
So you said that currently the way that microgrids are set up is to do a feasibility study, which costs on the scale of 100 grand, I think. How much are you planning to sell your solution for, and how is it a one-time sale? Is it a licensing fee, like a user fee? What's your revenue model?
I believe that we had covered this in one of these slides for here as the software as a service cost structure. Walker, I think you can elaborate on this a little bit.
Yep. So basically, if the I know the engineers are just getting started out, they obviously don't need all these sorts of fancy features, so they can start using the tool for free. And then if they're like, hey, this is really cool, but I'd like to get some recommendations, they could upgrade to the pro package. Then if they want more collaboration, they could upgrade to the collab, so on and so forth. So basically, you don't have to spend a lot of money if you're just getting started out, right? Because then if nothing happens, you just lost all that money.
So this is like going to be a cloud-based solution, not enterprise.
Yep, we're going to be using a lot of cloud-based tools, mainly hosted on AWS.
All right. Thank you very much. Team 10, the Grid Kids. If you would stop screen sharing, we'll now have Team 11, Revolutionary CO2 Tech, turn waste into profit from New Jersey Institute of Technology, set up their slides while our judges take a couple of minutes to record their thoughts. Thanks. All right. All right. Team 11, if the judges are all
You guys hear us?
Yes.
We're gonna use one mic. So it's gonna be my mic. We're sitting right next to each other. Yeah. All right. Ready? Hello, my name is Mohammed Hamed. I'm Nick Oshel, and we are Net Zero. We're dedicated to a net zero future with a profitable way, because why pay to store CO2 when you can sell it? Our pros technologies from a national lab, which is a mechanical and aerodynamic based system which separates CO2 from post-combustion by cooling multi-gas streams and solidifying CO2 while releasing the other gases. As you can see, the right-hand side, we have the schematic of the technology. So the first is supersonic nozzle. This brings the multi-stream gas up to supersonic speed, which will go through a converging and diverging lens, and then it will be hit by oblique shock waves, which basically knock out the solid CO2 and keep the other gases in their gaseous state. So majority of the current technology for CO2 removal is using refrigeration and compression. These systems are often very complex and uses a lot of energy. Our system uses no refrigeration nor compression, which means it uses a lot less energy and more cost effective for the user. Now, our business model is we want to license this CO2 removal technology to power plants and industry sites for third-party design and implementation to their facilities. Additionally, we want to connect to dry ice distributors and manufacturers to purpose and pick up our byproduct, which is solid CO2, or more commonly referred to as dry ice, directly from the site our technology is installed at. Now, why are we targeting them? 50% of all CO2 emissions come from electric power plants and industry. As you can see, 25 come from electric power, 24 for industry. Now, with the increasing federal regulations of CO2 emissions, this is basically to help out these industries, and also is a growing market. As you can see, there's a now to 2023, there is a 6.1% compound annual growth rate for the US carbon capture and storage market, which basically means there's increasing demand for carbon capture, utilization, and storage, or commonly referred as CCUS. So
These are the financial projections estimated for implementation of this technology. Using the parameters of a 500 milliwatt coal power plant as a base, we estimate that the cost of capture per ton using this technology for CO2 is $65.14 for a 65% capture efficiency of the technology, and $56.38 for a 90% capture efficiency. It's evident that this correlates to the decreasing price of CCUS through the trend line shown above. So market breakdown and market breakdown. In terms of selling this product, we're targeting the dry ice industry. The total availability market for this industry is $995 million globally. The serviceable available market for the North American region is $546 million industry, and the serviceable obtainable market is $269 million for the US region. And this value is forecasted to grow to $374 million by 2028. So our competitors are also our potential partners. This is a list of some of the greatest producers of dry ice in the US. And after calling and speaking with some of the companies and getting some information, we estimate that the cheapest these companies produce dry ice for is 16.67 cents per metric ton. And that's only for the power used by the machines that produce this. We can still sell this cheaper than it costs for them to even make. Here's the procedure and projected timeline and events for our business plan. Phase 1, we license the product to facilities to design, construct and construct with their own third-party firms. Phase 2, we target manufacturers in nearby regions and sign agreements that they buy our CO2 and schedule pickups with us. Phase 3, the system is operational and producing solid CO2, and clients are picking up their merchandise. And phase 4, the business operates and adjusts their costs and until net zero emissions is achieved by the US, which is planned to be for 2050. All right, as you can see, here are some estimate breakdowns for a power plant or fossil fuel in this facility to invest in this technology. We estimate that the total capital investment to get started in this is $245.8 million, which includes a $25 million licensing cost, which will be used to pay for storage facility for excess in CO2 production, dry ice production, as well as any licensing, any royalties paid to the actual inventor. This is less than the $500 million per unit, according to a DOE analysis, Department of Engineering analysis. 10-year forecast shows for a power plant or a fossil fuel facility, it takes 3.5 years to make their money back. And after 10 years, they make around $554 million cumulatively. In terms of our business finances, on a 10-year projection, we have a potential to make a profit of $843.43 million. This differs than the other companies because we were projected to convert 1 million tons for like a 500 megawatt power plant. Power companies will benefit and fossil fuel facilities benefit. Why? Because they're paying less than the average cost for capture. They're getting $100 that's tentative by us. They're getting paid $100 for a ton of CO2, and they get up to $60 in 45Q tax credit by the US government.
And this doesn't just benefit power companies or fossil fuel facilities. This also can benefit the environment. There'll be less underground reservoirs filled with CO2. Sometimes these reservoirs can leak and the CO2 gets out. The transition to zero emissions by 2050 as a federal standard and the EPA, this will help assist government mitigations for emission control in the industry. So we'd like to thank you guys for listening to our presentation, and special thank you to the U.S. Department of Energy, or DOE, and the Syracuse Center of Excellence. Thank you.
All right, thank you very much. Judges, we'll allow you the time to ask questions now.
What stage is the technology in? Has it been prototyped?
Yes.
So the technology has been prototyped in a national lab now we've been in contact with the actual inventor, John O, to get more information regarding the aspects of scaling it up. I hope that answers your question.
So so you call this a sequestration technology. I don't get it. The CO2 is converted to dry ice, but the dry ice turns back into CO2 that enters the atmosphere. I haven't quite understood why you call it sequestration.
So the technology is that is true. It's being converted back to CO2 let out in the atmosphere through the dry ice as it vaporizes, but it's making use of the CO2 as per the government regulations. So,
okay, so right, you concur. I mean, I'm not trying to say it isn't an interesting and good idea. There are others similar to that because we use a lot of CO2 in dry ice and in oil recovery, which is actually, I think, the largest market. But yeah, so, but it's not literally a sequestration, but the economic viability of it is determined by competition with the current technologies for dry ice production. I get that right? Okay.
Yes.
Okay, it's interesting.
I'm just a little bit confused on the business model. So you're licensing the technology to, say, a coal manufacturer, coal power plant. They're converting the carbon to dry ice and they can sell it, or you can sell it? Who owns the dry ice?
To clarify that, so we're licensing off the use of the technology.
Yep.
They get this license, they get the use of it, the rights to use it. They involve third-party engineers, firms to design and construct this technology on the scale by scale basis per plant. And it's their CO2, but we're buying it from them. So as per like the agreements, we pay them for the CO2 that's being produced, but we schedule, like we handle selling it yet again in wholesale to actual distributors of it, who then could sell to pharmaceutical companies or whatnot.
So what does it keep them from just developing those relationships and selling it direct? Why do they need you to middleman?
That's a very good, they don't have the access to this technology. So like, if they want to be in on it, like it's part of the.
So to get the technology, they have to sign an agreement with you that they will sell you the carbon.
Yes. Oh, yes. Basically, that's part of the deal. So they'll get paid for it and they'll get profit off of it instead of just paying to get it captured. They'll get paid for their CO2 and then we'll just handle like selling it, and they'll still get the credit, the 45Q credit, tax credit.
So does this technology encourage carbon emitting fossil fuel plants to, by giving them additional revenue sources, encourage them to remain rather than transitioning out?
So this does not encourage them to remain. This encourages them to implement new technologies and make use of CO2 and cheaper methods, because these power plants and companies are looking for the cheapest way to somehow meet these government regulations. So these are like, so this is trying to help them meet those regulations in the most cost-effective or cost beneficial or profitable way until like all these plants go, like run cold, which is the track for the US right now for the next, for now 30 years.
All right. Thank you very much. We will now allow the judges to take a few minutes to record their thoughts as we transition into our final pitch of the day. Thank you. And if Team 13 is here, feel free to begin sharing your screen as we just allow the judges to take a moment to wrap up. Team 13, Hydrogen and Energy Carrier for the Future, from New Jersey Institute of Technology and St. George's University School of Medicine.
Hi, I'm Jason Tejada. I'm here to present. Just give me a second while I get the slides ready.
Oh, take your time. We're still allowing the judges to take a couple of moments, so.
Perfect, thanks.
Mhm. And just as a reminder to the judges, this is team 13. We had 12 present earlier, so we are right at 13.
What is
All right, team 13, feel free to begin whenever you're ready.
okay? All right. Hello, everyone. I'm Jason. I have a few other my partners here, Adele, Abdel, and Eden. Everyone else is a little busy. But this is our pitch for hydrogen production, the future of electrolysis hydrogen, hydrogen production using hydrogen electrolysis. That's what we're going with today. We're going to go over the technology identification, market assessment, the feasibility, and the potential impact. So a little history on the hydrogen electrolyzer. It was developed in 1888. Basically, what this does is it takes a water molecule, splits it up into hydrogen 2 and oxygen in order to create the proper output or the proper chemical balance. We need 2 water molecules in order to make the hydrogen and the oxidized oxygen. Right now, the commercial technology that we have right now produces 53 kilowatts of 53 kilowatt energies per 1 kilogram of hydrogen, and this can be done using different types of water, seawater, groundwater, wastewater. We're going to focus on wastewater, but these are just some other applications that it can be used for, or other types of sources that it can be used with. There are 3 types: alkaline, which uses a nickel electrocatalyst proton exchange membrane, which uses platinum, and a solid oxide electrolyzer cell that we're not going to go over. We chose to go with the proton exchange membrane, which is the best available technology right now, that produces about 80%, that has an 80% efficiency. So basically, if we put in, basically we'll get 80% of energy from the substance that we use. We want to focus on delivering energy to potentially maritime facilities like seaports, or basically anywhere where there's cargo ships that could use renewable energy to help clean up their fuel waste while traveling across the sea. Hydrogen being a fuel that could already be used with existing internal combustion engines. We thought it might be a good idea to use the stored fuel that we'll obtain and sell it to these type of markets to help them clean up their footprint. These are some of the competitors that we have, not competitors, but these are some of the players already in the hydrogen electrolyzer market: Vertige, Thiosen, and Evolve Hydrogen, with a few notes on what they produce. Vertige has a 20 megawatt e-dynamic electrolyzer. We're planning to get a 10 megawatt electrolyzer for our needs today. And our goal is to reduce carbon emissions along with hopefully turn a profit. And yeah. So basically what we want to do is we want to take our hydrogen electrolyzer and apply it in places that already have wastewater treatment plants. It's not on the slide right now, I'm sorry. But we want to take our electrolyzer and apply it to places that have densely populated areas, as well as like surrounding bodies of water that could, as a source for our fuel. New Jersey is a good example. Densely populated, a lot of wastewater, and plenty of rivers, lakes, and ports in the area that could integrate the hydrogen electrolyzer and the plan that we plan to implement. So the idea is to take existing wastewater treatment plants. New Jersey has 25 of them, integrating an electrolyzer and applying this method of water refining and using it as a second method. Normally there's two methods. The first round of water treatment cleans the water 60%. The second round of treatment cleans it up to 90% and makes it reusable for the public or for the environment, reducing pollutants. We propose that if we can get a 10 megawatt electrolyzer, we could roughly produce 175 megawatt hours per day using the 10 megawatt electrolyzer. And the electrolyzer that we looked into would cost roughly, like, it's a lot of money, $30 to $50 million, and it will be enough to produce that much kilowatt hours of energy per day, 175.2 megawatt hours daily. It'll be enough to produce that, and on top of that, give us a surplus of 1 megawatt of power that within our initial cost for purchasing the electrolyzer that we looked into comes with 600 tons of hydrogen storage. So basically we'd use 9 megawatts of power for the electrolysis process. The remaining 1 megawatt of power will produce enough hydrogen to go into storage, which we could resell to the market, ideally places like the ports, as I mentioned earlier, so that they could use this energy on their fuel, they could use this gas for their fuel, or it can go back into the grid to help during off-peak hours, as this fuel could help power gas turbines engines, which go into effect on during peak hours. With that being said, we look we're looking at, for installation for one of these would be like $9 million, and then 30 to 50 million. So let's just call it 40. So we're looking at $40 million for the $40 million for the capital cost, $9 million for the installation, and roughly
I'll give you 30 seconds to wrap up, please.
$15,000 per day on electricity cost. New Jersey is a perfect place for this due to the fact that we are trying to be green, carbon free by 2050, and there's already a New Jersey master plan for energy that already exists. So yeah, our client would end up being the New Jersey government and the Department of Energy. Thanks.
All right, thank you very much. We'll now ask the judges if they have any questions.
So is your business model to be an operator of this facility?
No, our business model would be to to basically get these people to buy our electrolyzer. We will basically be like a middleman. We'll get everything together, help the wastewater treatment plants integrate their existing plant with this clean energy. So basically we'll be like I don't know, like a middleman of some sort.
Is the technology proprietary to you, or you would be accessing technology from another company?
We would be accessing technology from a separate company. Vertigy would probably be the best example. Someone like them, we would ask them to build something to the specifications that we need, which they already are capable of.
So you're purchasing it from Vertigy and then installing it somewhere and getting wherever you install it, pay you back for your capital costs.
Yes. And hopefully be able to, in addition, use that extra energy that we have from the electrolyzer to resell the surplus fuel to other industry needs, ideally in a market where we can make a better impact. The grid's pretty much stable, so ports and basically ships and whatnot need they're trying to go green too to minimize their carbon output. So yeah, that would be our business plan.
All right, thank you very much. That was our last pitch of the day. So if you would mind removing your screen so I can share this transition slide as we get ready to break for a little bit.
Thanks.
Thank you. Give me 1 second here. Oh, I'm experiencing technical difficulties now. Oh, all right. I guess I'll make my announcement first and then pull up the screen later. All right. So thank you to all of our student teams for those lovely pitches. We're now going to break for about half an hour to allow the judges to move over to a separate Zoom room and determine the winner for today. Student teams, you are more than welcome to remain in this room while that's occurring. There is a survey that DOE has asked the student teams to complete, and we will send a link for that survey in the chat box, and hopefully I'll be able to display a QR code on screen in a couple minutes here once I figure out what's going on with my screen share. So yes, we're expecting to reconvene at 4:15, and we'll have a winner by then. So thank you to our judges and thank you to our teams.
Good job, everyone.
Oh my God, no.
Yeah, you already know who it is. I just want to say good luck to everyone. And
Thanks, Camacho.
that's my boy. Salam alaikum. I'm the Greek warrior of love. Nice to meet you guys. I hope everyone gets, let's do this. All right, later, guys.
Thank you. Good luck to everyone.
Is anyone else here? Okay.
I think we're just waiting for the slides.
I was beginning to worry I was in the wrong place.
You're right where you belong.
Perfect.
That's a good sign.
I'm catching Pokemon while we wait.
Almost there, almost there.
That's okay. Take your time.
Judges aren't eligible, right? No awards for us.
Maybe they should implement that. Actually, I think that'd be a good suggestion.
You could just send a good bottle of wine. That would be sufficient.
I was gonna say donuts, wine.
No donuts. Good idea.
We do have a little something special for our judges for sure.
Donuts and wine sound like my Friday night plans. Wow.
All right. Okay, we've got everything. Everyone can see the screen, right? I'm assuming yes.
Yes.
All right, great. I'm hoping that our student teams are back in the Zoom. Let me have a look here. Because this is the most exciting part. Now we get to reveal our winners. Okay, I'm going to go ahead and assume that our student teams are with us. Okay, so thank you very much for your patience during that deliberation period. We're now ready to announce not only our semifinalist and our regional winner, but also 4 nominees for technology bonus prizes. Let me click. Can I click here? Let's see.
You guys are just adding to the suspense.
The suspense.
Yeah. All right, the suspense. I know
is building
it's all planned. All right, we're ready here. So for our first technology bonus prize, we have from the Office of Fossil Energy and Carbon Management, our regional nominee, who is Team 9. HVAC capture, direct air capture on an HVAC system from Columbia University. Very exciting for them. Congratulations to Team 9. And then for our second technology bonus prize, we have from the Office of Electricity's Grid Enhancing Technology, our regional nominee, who is Team 10, Grid Discovery from Stevens Institute of Technology. Very exciting, and congratulations to Team 10. And then our third prize from the Office of Solar Energy Technology. Our regional nominee for this prize is Team 8, Heliotrope, Efficiency Boosting Thin Films for Solar Panels of NYU. Congratulations to Team 8. And then for our last technology bonus prize, we have from the Office of Electricity's Large Power Transformers. Regional nominee is Team 3, TransX Automated Transit System of Rutgers University. So those are all of our technology bonus prize nominees. Very exciting, and congratulations to those 4 teams. And then, for our big regional winner, this team is going to go on and compete in the National Energy Tech Up competition. And our NYC Metro Regional winner for today is Team 8. Congratulations to Team 8, Heliotrope Efficiency Boosting Thin Films for Solar Panels of NYU. Congratulations, and we all cannot wait to see how you do on the big stage. Congratulations.
Congratulations, everyone.
Yes.
Yep.
Congrats.
All right, and thank you to all of our student teams, especially
work, everybody.
our judges as well. Thank you very much to our judges. We appreciate your time. Thank you to the student teams for that incredible effort. And of course, thank you to Syracuse COE hosts, NYSERDA, and U.S. Department of Energy. I hope everyone has an amazing weekend, and I'm sure we all can't wait to see where these teams end up. So thank you very much, everyone.
Well done. Have a good weekend.
Thank you, Kai. Congratulations.
Yes, congrats, everyone.
Thanks, Kai.
Thank you. Thank you.